Today we are going to be talking about the reasonableness of sums and differences, which is a big word, reasonableness, but it just means, does it make sense? Does your sum, does your answer to an addition problem, or does your difference, your answer to a subtraction problem, make sense? Which is a great skill for us to have, because that's just estimating. We do it in real life all the time. We need to see if something is reasonable. If you are planning a party and you want everybody to have 2 slices of pizza, you kind of have to make an estimate of something reasonable that you should buy. If you have 4 friends and you want them to each have 2 slices of pizza, well, then you would need 8 slices of pizza. So it wouldn't be reasonable for you to buy 12 pizzas, because that would be way, way, way too much for you and your 4 friends. So that's what we're going to be talking about when we're saying, is this reasonable? Does it make sense? Is it close to what we think it should be? Okay? So we are in our book, our module 10 through 20 book again. Remember at the bottom it says 10 through 20. I know y'all have a lot of books you're going through. We have a 1 through 9 book, a homework book, and a 10 through 20. We're looking at 10 through 20. And we are on page 347. So I want you guys to follow along with me. On page 347, you should be writing in your book along with me while we look at this. Okay, so we can use benchmarks or rounding to check the reasonableness. Okay, so a benchmark is a number close to something. So if we have $1.85, we could say that's about $2. Okay, that's a benchmark. It's something close to it that you can easily do in your head. So when we discuss fractions, I use 0, a half, and a whole as a benchmark, because that's something that we can quickly do in our mind. It might vary when we're doing decimals, because sometimes you could round it to the nearest tenth or the nearest whole number. It just kind of depends. You need to use something that is easy for you to do in your head. That's the whole point of this, is to figure it out and find a reasonable estimate. But this is not really as much doing the work as much as it is thinking about what would make sense. Okay, so it says Mr. Gilbert downloads 2 files onto his computer. The table shows the sizes of the 2 files. He says that he downloads about 2 megabytes of data. All right, so we can see that file 1, and we'll just write it real big over here, is 1 27/100. File 2 is 1 79/100. So remember, Mr. Gilbert said, I've done about 2 total. He thinks he's done about 2. So we need to look at this and say, if I put these 2 values together, would that be about 2? All right. So if we were here together, I would ask you to just think for a second, what would be a good way to estimate or round or make a benchmark for our numbers? Now, one way we can do that is by representing a number line. So you can draw a number line on your paper, just so we can kind of get an idea about our numbers. So I'm just going to say 0, 1, 2, and 3, okay? So now that I've got this here, and please don't worry about how yours looks, not a big deal, this is just for you. So I'm going to say, where on this number line would 1 27/100 be located? Well, one thing we know is it's 1 and something. So we know we're at 1 and something. Let's think about 27/100. Am I going to be right in the middle of the 1 and 2, less than the middle, or more than the middle? Think about it like money. This is, if half of that would be, let's say, 50 cents, then maybe 1 27/100 would be somewhere about right here. Again, this doesn't have to be perfect. This is just for us. This is an estimate. So I know that that's about where that number is. All right. Then for 1 79/100ths. Again, we know it's more than 1, but this is 79/100ths. So we're thinking, oh, our lights went out. There we go. So we're thinking, okay, 1 and 79, if we think about it like money, 79 cents, that's almost $1. I know it's going to be more than halfway. So let's put our 1 and 79/100ths right here. We could even argue and say that's pretty close to the 2. Okay, so now that we've got that there, let's think about, does his answer make sense? If we put these two values together, is it going to be about 2, the whole number 2? Well, I don't think we can say that his answer is correct, because 1 and 79/100ths, that's almost 2 by itself. So that's another thing we could do. We could look at our numbers and say, okay, if I was to round 1 and 79/100ths, I would say that's about 2. Now, when I was in high school, we would make these funny little equal signs. They were wiggly because it wasn't necessarily equal. It was just helping us know what we rounded it to. So I would round that to about 2. And 1 and 27/100ths, you could either round to 1 or 1 1/2, 1 and 5/10, because it's definitely not close to 2 though. We could round it to 1 or 1 1/2. Just for the ease of this, I'm just going to round it to 1 because it's less than that 50. You know, just like when we're rounding, like you did last year in 4th grade. 5 or more, let it soar. 4 or less, let it rest. This is closer to 1 than it is 2. So we're going to keep it at 1. So if we were to estimate, if file 1 is about 1 and file 2 is about 2, together that would be about 3. So I'm going to say no, it's not reasonable. His amount is, we can just say, is greater than 2, because right now we didn't find an exact answer, but we know that it's not going to be just 2. We know it's going to be greater. Just 1 plus 1 is 2. If we've got, let's say, 79 cents and 27 cents, we can probably figure out in our head that's also going to give us a whole number when we add those together. So no, his is not reasonable. Now, again, I always think it's a good strategy to just double check. So now that we've figured out is it reasonable or not, over here on the side of my paper, it's not going to hurt us one bit. Let's just solve it and see. 7/100ths and 9/100ths. 7 and 9 is going to give me 16/100ths. 7, 8, 9, 10. So I made 10 tenths, which gave me another whole. And if I add those together, I get 3 and 6/100ths, which is way more than 2. So that's how we're proving and showing that his answer really isn't reasonable. Okay? So let's turn the page. So now we're on page 348. And let's read number 1. Let me get it where y'all can see it. The table shows the sizes of 2 different video files. Miss Lee says she uses 22/100ths gigabyte more for file A than for file B. That she uses a total of 96/100ths for both. Locate points on the number line to show the size of each video file. Okay, so let's look at video file A first. It is 74/100ths. Let's look at our number line. I see 25/100ths. You can say 50/100ths or 5/10ths. Let's scoot on in here. 75/100ths. Well, 74 comes right before 75. So I'm going to stick that right there. I mean, just right on top of that 75. 52/100ths. It's going to be a little bit more than that 50, isn't it? All right. So we've got that there. All right. Now, it says which benchmarks on the number line can you use to estimate the size of each video file? So if we look at that number line, there's really only one, or it's really kind of easy for us to choose what we would use, right? Our numbers are super close to some other ones. I would say 50 or 50 hundredths or 5 tenths, and I would say 75 hundredths because our numbers are so close, and that's easy for us to calculate in our minds, okay? All right, so then it says, is Miss Lee's statement that she uses 22 gigabytes more reasonable? Explain how you know. All right, now I can't help but think of quarters when I see these numbers, right? 25, 50, 75, $1. I think about quarters. So then that makes me think, okay, I know that 50 cents, I only need one more quarter to give me 75. And a quarter is worth how much? 25 cents. So if I'm just estimating quickly in my mind, they're 25 hundredths apart. So remember, she guessed 22 hundredths. Is 22 hundredths close to 25 hundredths? Yeah, 22 cents is close to 25 cents if we think about it like that. So I would say yes, her estimate is reasonable. I mean, she's only 3 hundredths, you know, away from how we're estimating right here. So I would say yes, her estimate is reasonable because when we calculate it, we get 25 hundredths, and that's close to 22 hundredths. All right, so that was the difference in them. But D says, if Miss Lee's statement, is Miss Lee's statement that she uses a total of 96 gigabytes for both video files reasonable? Sorry, y'all, that you couldn't see that. I'm very sorry. So now we're looking and saying, okay, we thought that she was reasonable here with her difference. So now let's look at those same numbers again, because now she's saying her total, the sum when we put it together. So let's look at these. If I have 75 hundredths and I add 50 hundredths, think about it like money. If I have 75 cents and I add 50 cents, is it going to be 96? Is it going to be less than $1? No. Think about it. If we have 2 more quarters and we have 75 cents, 1 more quarter is going to be $1. Another quarter is going to be $1.25. So I don't think her answer is as reasonable this time, because our answer is going to be much greater than what she said. Okay, so I'm not going to agree with Miss Lee this time. I'm going to say 96 hundredths is too small. Her total will be over 1. Okay? I mean, we can even say around 1 and 25 hundredths is what our estimate would be, which is much bigger than what she said. Okay? All right? So that's what we're talking about today. We're just looking and seeing, does something make sense? Is it reasonable? Okay? Got another one. Let's see if we can do one more. Okay. All right. So for number 2, the table shows a cell phone provider's monthly charges. What is the difference in cost? Okay, what is the difference? We've got this cost and this cost. What's that difference? What's that in between? Mr. Sanchez says the difference is $23.23. Is his answer reasonable? So looking right over here, you see these costs on your book. We're on page 349. Voice services are $12.72. First, let's do a reasonable estimate. And it's up to you how you do that. You might want to round your voice service to $13, or you might change your voice service to $10 if you're rounding that way. Doesn't matter. Then let's look at the data. If you're just going to round it to the nearest one, then if I look next door and see that 9, I might round that to $36. But if you're rounding it to the nearest 10, you might say, well, that's about $40. It doesn't matter. It's whatever is reasonable for you. That's the whole point of that. So if we rounded both of them to the nearest dollar, then we'd have $13 and $36. So we could say, okay, 36 minus 13 is 23. If I did it this way, $40 minus $10 is 30. Okay, now we've got to look at that and say, okay, now when I rounded to my nearest dollar, yeah, he is spot on with his estimate. So even though this estimate, your 10 and your 40, was probably faster for you to do in your head, remember, it's not going to be as exact because you changed your number more. You know, you changed 35 all the way to 40. That made a difference of $5. But in this case, when you rounded them just to the nearest $1, you didn't change them very much. So that's going to help you get a more exact answer, okay? So I would say, okay. So let's read the directions. A says estimate the difference by rounding each cost to the nearest $10. Okay, that's what we did. 40 minus 10 equals 30. Estimate it by rounding each one to the nearest dollar. We got 36 minus 13, and we got 23. Is he reasonable? Yeah, he said $23.23. That's very close to our estimate. Okay. All right, guys, so that's what we're doing today. We are just figuring out, is something reasonable? Does it make sense? And those are some strategies on how you can do that.